The Little Handbook of AI by Steve Hovland. Contents: 1. Overview. 2. AI and Machine Learning Fundamentals. 3. Data Management. 4. Ethics and Responsible AI. 5. AI Strategy and Implementation. 6. Regulatory Compliance. 7. Innovation Management. 8. Stakeholder Engagement. 9. Talent Acquisition and Development. 10. Vendor and Technology Selection. 11. Risk Management. 12. Performance Metrics and ROI. 13. Industry Trends and Best Practices. 14. Scalability and Infrastructure. 15. Cross-disciplinary collaboration. 16. Change Management. Chapter 1. Overview. AI and Machine Learning Fundamentals. Understand the core principles, algorithms, and technologies that drive AI and machine learning. This includes deep learning, natural language processing, and computer vision. Data management. Know how to manage and govern large datasets, ensuring quality, privacy, and accessibility. This includes understanding data architecture, data lakes, and cloud storage solutions. Ethics and responsible AI. Be well-versed in ethical AI practices, including fairness, accountability, transparency, and the mitigation of biases. Understand the importance of ethical guidelines and frameworks in AI development and deployment. AI strategy and implementation. Develop a clear AI strategy that aligns with the organization's goals. This includes understanding how to implement AI projects, from ideation to deployment and scaling. Regulatory compliance. Stay informed about global and regional regulations affecting AI and data privacy, such as GDPR in Europe and CCPA in California. Ensure that AI projects comply with these regulations. Innovation management. Foster a culture of innovation within the organization, encouraging experimentation and the adoption of new AI technologies and methodologies. Stakeholder engagement. Effectively communicate and collaborate with stakeholders across the organization. This includes IT, data science, legal, HR, and executive teams to ensure buy-in and support for AI initiatives. Talent acquisition and development. Know how to attract, retain, and develop AI talent, including data scientists, machine learning engineers, and AI ethicists. Vendor and technology selection. Evaluate and select AI technologies and vendors, understanding the landscape of AI tools, platforms, and services available in the market. Risk management. Identify and mitigate risks associated with AI projects, including technical, ethical, and reputational risks. Performance metrics and ROI. Define and track key performance indicators and return on investment for AI projects to measure success and guide future investments. Industry trends and best practices. Stay up to date with the latest AI research, technologies, and industry best practices to ensure the organization remains competitive and innovative. Scalability and infrastructure. Understand the infrastructure needs of AI projects, including compute resources, data storage, and networking, to ensure projects can be scaled effectively. Cross-disciplinary collaboration. Promote collaboration between different disciplines within the organization, such as between data scientists, domain experts, and operational teams, to ensure AI solutions are effectively integrated and add value. Change management. Lead change management efforts related to AI adoption, ensuring that employees are trained, processes are adapted, and the organization is culturally ready for transformation. Understanding of these areas can drive successful AI initiatives, navigating the complexities of technology implementation while ensuring ethical, regulatory, and strategic alignment with the organization's objectives. Chapter 2: AI and Machine Learning Fundamentals. Understanding AI and machine learning fundamentals is crucial for leveraging these technologies effectively. Artificial intelligence. AI is a broad area of computer science focused on creating systems capable of performing tasks that typically require human intelligence. These tasks include problem solving, understanding natural language, recognizing patterns, and learning from experience. Machine learning. ML is a subset of AI, where algorithms learn from data to make predictions or decisions without being explicitly programmed for the task. It involves feeding data to algorithms to help them learn and improve their accuracy over time. Types of machine learning. Supervised learning. The model learns from a labeled data set, trying to predict the output from the input data. It's used for classification and regression tasks. Unsupervised learning. The model works with unlabeled data to find patterns and relationships in the data. Common uses include clustering and dimensionality reduction. Reinforcement learning. The model learns to make decisions by performing actions in an environment to achieve a goal. It learns from trial and error, receiving rewards or penalties. Neural networks and deep learning. Neural networks. Inspired by the human brain, these are a series of algorithms that capture relationships in data through a process that mimics how neurons transmit signals in the brain. Deep learning. A subset of ML involving neural networks with many layers. It's particularly powerful for tasks like image and speech recognition. Key algorithms. Regression. Used for predicting continuous values, for example, price forecasting. Classification. Used for predicting which category an object belongs to, for example, spam detection. Clustering. Groups similar data points together, for example, customer segmentation. Decision trees. A model that uses a tree-like graph of decisions and their possible consequences. Random forests. An ensemble method using multiple decision trees to improve prediction accuracy. Gradient boosting machines. Sequentially adding predictors to correct errors made by previous predictors. Neural networks can model complex nonlinear relationships. Evaluation metrics. Accuracy. The proportion of true results among the total number of cases examined. Used for classification tasks. Precision and recall. Precision is the ratio of true positives to all positive predictions. Recall is the ratio of true positives to all actual positives. Mean absolute error, MA, and mean squared error, MSE. Measures of error for regression models. Data preprocessing. Data needs to be cleaned, normalized, and transformed so it can be effectively used by ML models. This may involve handling missing values, encoding categorical variables, and scaling features. Bias and variance. Bias. Error from erroneous assumptions in the learning algorithm. High bias can cause an algorithm to miss relevant relations, underfitting. Variance. Error from sensitivity to small fluctuations in the training set. High variance can cause overfitting to the training data. Ethical considerations. The development and deployment of AI and ML must be approached with ethical considerations in mind, including ensuring fairness, accountability, and transparency, and avoiding bias. By mastering these fundamentals, you lay the groundwork for exploring more advanced AI and ML concepts and technologies, enabling the development of sophisticated and effective AI systems. Chapter 3: Data Management. Effective data management is foundational to the success of AI and machine learning initiatives. It encompasses a broad set of disciplines and practices aimed at ensuring the accessibility, reliability, and security of data used in organizational operations and decision-making processes. Here's a breakdown of key aspects in data management: data strategy and governance. Data strategy: establishing a clear strategy that outlines how data will be collected, stored, managed, shared, and used to support business objectives. Data governance: implementing policies and procedures to manage data availability, usability, integrity, and security, often overseen by a governance body or data stewards. Data quality: accuracy, completeness, consistency. Ensuring data is accurate, complete, and consistent across different systems. This involves processes for cleaning data, handling missing values, and correcting inaccuracies. Validation: implementing checks and balances to maintain data quality throughout its lifecycle, including data entry points and ongoing data maintenance practices. Data architecture: storage and organization. Deciding on the structure of database systems, SQL versus NoSQL, data warehouses, and data lakes. This also includes considerations for cloud-based versus on-premises storage solutions. Data modeling: designing data models that dictate how data is connected and stored, which impacts how it can be queried and analyzed. Data security: access control, ensuring only authorized individuals can access sensitive data using role-based access controls, encryption, and secure authentication methods. Compliance: adhering to regulatory requirements related to data protection, such as GDPR, CCPA, and HIPAA, which dictate how data can be collected, processed, and stored. Data integration and interoperability: ETL processes, extract, transform, load, ETL processes are crucial for consolidating data from various sources into a single repository, making it usable for analysis and insights. APIs and middleware: utilizing application programming interfaces, APIs, and middleware to facilitate data sharing and integration between different systems and services. Master data management, MDM. Single source of truth: establishing a master record, or single source of truth, for critical business entities like customers, products, and employees, which is consistently used across the organization. Data lifecycle management. Retention and archiving: defining policies for how long data should be retained, how it should be archived, and when it should be deleted, in compliance with legal and business requirements. Data analytics and reporting. Tools and platforms: implementing tools and platforms that support data analysis, business intelligence, and reporting, enabling organizations to derive actionable insights from their data. Big data technologies. Frameworks and systems: leveraging big data technologies such as Hadoop, Spark, and NoSQL databases to process and analyze large volumes of data efficiently. Privacy and ethical considerations. Privacy by design: integrating privacy considerations into the development and operation of AI and ML systems, ensuring that personal data is handled ethically and in compliance with privacy laws. Effective data management is not just about handling data, but also about enabling an organization to make data-driven decisions, innovate, and maintain competitive advantage. By addressing these aspects, organizations can ensure that their data assets are accurate, secure, and leveraged to their full potential. Chapter 4: Ethics and Responsible AI. Ethics and responsible AI are crucial to ensuring that AI technologies benefit society while minimizing harm. These principles guide the development, deployment, and use of AI systems in a manner that respects human rights, fairness, and dignity. Here's an overview of the key concepts and practices in ethics and responsible AI. Transparency. Explainability. AI systems should be transparent and their decisions understandable to users and stakeholders. This involves creating models that can explain their decisions in human-readable forms. Openness. Sharing information about AI system design, operation, and governance to foster trust and accountability. Fairness and bias mitigation. Bias detection and correction. Identifying and mitigating biases in AI algorithms and datasets to prevent discriminatory outcomes. This includes biases related to race, gender, age, and other demographic factors. Equitable outcomes. Ensuring AI systems do not perpetuate inequality, but instead promote fairness in their applications. Privacy and data protection. Data privacy. Implementing measures to protect individual privacy and ensure data security, including adherence to data protection regulations like GDPR. And CCPA. Consent and autonomy. Ensuring individuals have control over their data and are informed about how their data is used in AI systems. Accountability and responsibility. Clear responsibility. Establishing clear lines of accountability for AI systems outcomes, including mechanisms for redress when harms occur. Human oversight. Ensuring that human judgment plays a central role in the deployment of AI, including mechanisms for human intervention and oversight. Safety and security. Robustness. Building AI systems that are secure and resilient against attacks, errors, or unexpected uses that could cause harm. Safety measures. Implementing procedures to evaluate and mitigate potential risks associated with AI systems throughout their lifecycle. Social and societal impact. Social welfare. Assessing the impact of AI on social structures, employment, and community well-being, and striving to enhance societal benefit. Inclusive design. Creating AI systems that are accessible to and usable by people with different needs. Governance. Ethical governance frameworks. Developing and implementing governance frameworks that embed ethical considerations into the AI development process. Multi-stakeholder collaboration. Engaging with a broad range of stakeholders, including civil society, policymakers, and affected communities, to guide responsible AI development and use. Implementation strategies. Ethical AI guidelines and standards. Adopting and promoting ethical guidelines and standards for AI development and deployment. Ethics training for AI practitioners. Providing education and training for developers, data scientists, and executives on ethical AI practices. Ethical review boards. Establishing review boards or ethics committees to evaluate AI projects for ethical considerations and societal impact. Chapter 5. AI Strategy and Implementation. Developing and implementing an AI strategy is pivotal for organizations looking to leverage AI to drive innovation, efficiency, and competitive advantage. A comprehensive AI strategy encompasses understanding current capabilities, identifying opportunities for AI application, and managing the deployment and integration of AI technologies within existing systems and processes. Here's an outline to guide the development and execution of an effective AI strategy. Assess current capabilities and needs. Audit existing data and infrastructure. Evaluate the quality, accessibility, and structure of data. Assess the current IT infrastructure to support AI technologies. Skills and talent assessment. Identify in-house AI expertise and areas where talent acquisition or training is needed. Define AI vision and objectives. Align with business goals. Ensure the AI strategy supports overarching business objectives, such as improving customer experience, increasing operational efficiency, or driving innovation. Identify high-impact use cases. Select AI projects that offer significant value with manageable risk. Prioritize initiatives based on strategic importance and feasibility. Develop an ethical framework. Incorporate ethics and responsibility. Establish guidelines for ethical AI use, addressing fairness, transparency, privacy, and accountability. Regulatory compliance. Ensure the AI strategy is compliant with relevant laws and regulations, including data protection and privacy laws. Establish a governance structure. Leadership and oversight. Create a governance model for AI initiatives, defining roles, responsibilities, and decision-making processes. Cross-functional collaboration. Promote collaboration between IT, data science, legal, HR, and business units to ensure alignment and integration of AI projects. Build or acquire AI capabilities. Technology infrastructure. Decide whether to build in-house AI solutions, use off-the-shelf AI products, or a combination of both. Consider cloud-based AI services for scalability and flexibility. Talent development and acquisition. Invest in training existing staff or recruit AI specialists. Consider partnerships with academic institutions or service providers. Data management and architecture. Robust data strategy. Ensure access to high-quality, relevant data. Develop a data architecture that supports AI analytics and model development. Data privacy and security. Implement strong data governance practices to protect sensitive information and comply with regulatory requirements. Implement AI projects. Pilot projects. Start with pilot projects to test AI solutions in controlled environments. Use findings to refine approaches and build support for wider adoption. Agile development and iteration. Adopt agile methodologies for AI project development, allowing for rapid iteration and adaptation based on feedback and results. Monitor, evaluate, and scale. Performance metrics. Establish metrics to evaluate the performance and impact of AI initiatives against defined objectives. Continuous learning and adaptation. Incorporate feedback loops for continuous improvement of AI models and strategies. Scaling successful initiatives. Identify successful AI projects for broader implementation across the organization, ensuring scalability and integration with existing systems. Foster an AI culture. Change management. Support change management efforts to foster an AI-positive culture, addressing fears and misconceptions about AI among employees. AI literacy. Promote AI literacy across the organization to empower employees to engage with AI tools and understand their benefits and limitations. Ethical considerations and societal impact. Stakeholder engagement. Engage with stakeholders, including customers, employees, and regulators, to address concerns and communicate the benefits and ethical considerations of AI initiatives. Societal impact. Consider the broader societal implications of AI technologies and strive to contribute positively to communities and the environment. Implementing an AI strategy requires careful planning, commitment from leadership, and ongoing evaluation to adapt to new developments and lessons learned. By following these guidelines, organizations can navigate the complexities of AI integration and harness its potential to drive meaningful business outcomes. Chapter 6: Regulatory Compliance. Regulatory compliance in the context of AI involves adhering to laws, guidelines, and standards that govern the development and deployment of artificial intelligence technologies. As AI systems increasingly affect various aspects of daily life and business operations, governments and international bodies are establishing frameworks to ensure these technologies are used responsibly, ethically, and safely. Compliance is crucial for protecting consumer rights, ensuring privacy, and maintaining public trust in AI applications. Here's an overview of key areas in AI regulatory compliance: data protection and privacy. General Data Protection Regulation, GDPR. Enforced by the European Union, GDPR imposes strict rules on data processing and privacy, including the use of personal data in AI systems. It includes rights for individuals, such as access to their data, the right to be forgotten, and the right to explanation of AI decisions that affect them. California Consumer Privacy Act, CCPA. Similar to GDPR, the CCPA provides California residents with rights over their personal information, affecting companies that collect data from Californians. Other jurisdiction-specific laws. Many countries and regions have their own data protection regulations that companies must comply with when deploying AI solutions. Bias and fairness. Algorithmic accountability. Regulations focusing on algorithmic accountability require organizations to ensure their AI systems do not result in discriminatory outcomes. This involves transparency in AI decision-making processes and efforts to mitigate bias. Equality and anti-discrimination laws. Existing laws on equality and anti-discrimination also apply to AI systems, particularly in sectors like employment, finance, and healthcare, where AI decisions can significantly impact individuals. Transparency and explainability. Right to explanation. Under laws like GDPR, individuals have the right to an explanation of decisions made by automated systems. This requires AI systems to be designed in a way that their decisions can be understood and explained to users. Transparency guidelines. Various organizations and regulatory bodies have issued guidelines on AI transparency, advising companies on how to document and disclose the workings of their AI systems. Security and safety. Cybersecurity regulations. AI systems must comply with cybersecurity laws and standards to protect against unauthorized access and ensure the integrity of AI data and algorithms. Product safety and liability laws. For AI integrated into products or services, existing safety and liability laws ensure that these offerings do not pose risks to consumers. Compliance may involve risk assessments and adherence to safety standards. Sector-specific regulations. Healthcare. AI applications in healthcare must comply with regulations like the Health Insurance Portability and Accountability Act, HIA-PAIA, in the U.S., which protects patient data privacy. Finance. In the financial sector, AI systems must comply with regulations governing financial practices and data security, such as the Sarbanes-Oxley Act or the Payment Card Industry Data Security Standard, PCI DSS. International standards and guidelines. ISO standards, the International Organization for Standardization, ISO, and other bodies are developing standards for AI, including aspects like performance, ethics, and governance. Ethical frameworks. Guidelines from organizations such as the OECD, IEEE, and AI ethics bodies provide frameworks for responsible AI development, emphasizing principles like fairness, accountability, and societal benefit. Compliance programs and audits. Internal compliance programs. Organizations should establish internal compliance programs that include regular audits, risk assessments, and training for employees on legal and ethical AI practices. Third-party audits. External audits by third parties can help validate compliance with AI regulations and standards, providing an objective assessment of practices. Navigating AI regulatory compliance requires a thorough understanding of applicable laws and standards, as well as proactive measures to ensure AI systems are designed and operated in a legal, ethical, and socially responsible manner. As AI regulations continue to evolve, staying informed and engaged with regulatory developments is crucial for organizations leveraging AI technologies. Chapter 7. Innovation Management. Innovation management is the systematic process that organizations use to create new opportunities and realize ideas that can transform into practical and valuable new products, services, processes, or business models. It involves managing the entire life cycle of innovation, from idea generation to implementation, and often beyond to diffusion and scaling. Effective innovation management can significantly enhance an organization's ability to adapt, compete, and succeed in rapidly changing markets. Here are key aspects of innovation management: strategy and leadership. Strategic alignment. Ensuring that innovation efforts align with the organization's overall strategy and objectives. Leadership commitment. Senior leadership must actively support and champion innovation, providing clear vision and commitment. Culture and environment. Fostering an innovative culture. Creating a culture that encourages creativity, risk-taking, and learning from failure. This involves promoting open communication and collaboration. Innovation ecosystem. Building an ecosystem that supports innovation, including partnerships with other companies, universities, research institutions, and startups. Idea management. Idea generation. Implementing systematic processes for generating, capturing, and evaluating ideas. This can include brainstorming sessions, innovation workshops, and crowdsourcing platforms. Selection and prioritization. Developing criteria to evaluate and prioritize ideas for further development, considering factors such as feasibility, potential impact, and alignment with strategic goals. Process and tools. Innovation process. Establishing a clear process that guides ideas from conception through to implementation. This often involves stages of ideation, development, prototyping, testing, and scaling. Tools and technologies. Utilizing digital tools and platforms to manage the innovation process, including project management software, collaboration platforms, and innovation management systems. Resources and capabilities. Resource allocation. Ensuring that sufficient resources, time, budget, personnel, are allocated to innovation projects. Building capabilities. Developing the necessary skills and capabilities within the team, including creative thinking, project management, and technical expertise. Collaboration and open innovation. Internal collaboration. Encouraging cross-functional teams and internal collaboration to bring different perspectives and expertise to innovation projects. Open innovation. Embracing open innovation by collaborating with external partners, customers, and other stakeholders to source ideas and accelerate development. Risk management and experimentation. Embracing failure. Recognizing that not all innovation projects will succeed and adopting a mindset that values experimentation and learning from failure. Risk assessment. Implementing strategies to identify, assess, and manage risks associated with innovation projects. Measurement and improvement. Innovation metrics. Establishing metrics to measure the performance and impact of innovation activities, such as the number of new products launched, revenue from new products, or improvements in operational efficiency. Continuous improvement. Continuously reviewing and refining the innovation process, learning from both successes and failures. Scaling and diffusion. Scaling innovations. Strategies for scaling successful innovations within the organization and beyond to maximize impact. Knowledge. Sharing. Sharing lessons learned and best practices both internally and with external partners to foster continuous learning and improvement. Effective innovation management requires a holistic approach, integrating strategy, culture, processes, and tools. By systematically managing innovation, organizations can enhance their adaptability and resilience, driving growth and creating value in a constantly evolving marketplace. Chapter 8. Stakeholder Engagement. Stakeholder engagement is a crucial component of successful projects, policies, and strategic initiatives, particularly in areas involving complex technologies like AI. It involves the systematic identification, analysis, planning, and implementation of actions designed to involve those groups and individuals who can affect or are affected by the outcomes of these initiatives. Effective stakeholder engagement ensures that decisions are made transparently and with a broad base of support, enhancing the legitimacy and quality of outcomes. Here's how to approach stakeholder engagement effectively. Identify stakeholders. Mapping. Begin by identifying and categorizing stakeholders according to their interest, influence, and impact on the project. Stakeholders can range from internal parties, like employees and management, to external ones like customers, partners, regulators, and the broader community. Understand stakeholder needs and expectations. Analysis. Assess the needs, expectations, and concerns of different stakeholder groups. Understanding these factors is crucial for addressing concerns, managing expectations, and fostering supportive relationships. Prioritization. Some stakeholders will have more influence or be more significantly affected than others. Prioritize engagement activities accordingly, focusing on those with the highest interest and impact. Develop an engagement plan. Strategies. Tailor engagement strategies to different stakeholder groups, considering the most effective methods and channels for communication. This might include meetings, workshops, surveys, public forums, and digital platforms. Objectives and metrics. Define clear objectives for stakeholder engagement and establish metrics to measure the effectiveness of engagement activities. Communicate effectively. Transparency. Maintain an open and transparent communication strategy, providing stakeholders with timely and relevant information. This builds trust and facilitates constructive dialogue. Two-way communication. Engagement should be a two-way process, where feedback from stakeholders is actively sought, listened to, and acted upon. This can provide valuable insights and foster a sense of ownership and support among stakeholders. Build and maintain relationships. Trust building. Develop and maintain relationships with key stakeholders through regular updates, acknowledging their contributions, and demonstrating how their input has influenced the project. Partnerships. Look for opportunities to turn stakeholders into partners, particularly when their involvement can add value to the project or initiative. Monitor and adapt. Feedback loops. Establish mechanisms for ongoing feedback from stakeholders, allowing for continuous monitoring and adaptation of strategies in response to stakeholder concerns and changing project dynamics. Responsive actions. Be prepared to adjust plans based on stakeholder feedback and evolving project needs, demonstrating responsiveness and flexibility. Evaluate engagement activities. Review and learn. Regularly review the effectiveness of stakeholder engagement activities against the established metrics. Use these evaluations to learn and improve future engagement efforts. Report back. Share the outcomes of engagement activities with stakeholders, including how their input has influenced decisions. This reinforces the value of their involvement and supports ongoing engagement. Effective stakeholder engagement is dynamic and iterative, requiring continuous attention and adaptation. By placing stakeholders at the heart of the process, organizations can ensure that their initiatives are more inclusive, better informed, and more likely to achieve widespread acceptance and success. Chapter 9. Talent Acquisition and Development. Talent acquisition and development are critical components of an organization's success, particularly in fields like AI, where the demand for skilled professionals outstrips supply. A strategic approach to attracting, hiring, and nurturing talent not only fills immediate skills gaps, but also builds a sustainable talent pipeline for the future. Here are key strategies for effective talent acquisition and development in the context of AI and technology-driven sectors. Define clear job roles and requirements. Specificity. Clearly define the skills, experience, and qualifications required for each role, focusing on both technical and soft skills. Future-oriented. Consider future needs and emerging technologies when defining roles, anticipating the evolution of AI and related fields. Leverage multiple recruitment channels. Broad reach. Use a mix of traditional job postings, online platforms, social media, and professional networks to reach a broad candidate pool. Specialized forums. Engage with AI and tech communities through forums, online groups, hackathons, and conferences to attract talent actively involved in these fields. Employer branding. Value proposition. Develop a strong employer brand that highlights your organization's culture, mission, and the opportunities you offer for growth and impact in the AI field. Visibility. Showcase your organization's AI initiatives and achievements through media, blogs, case studies, and speaking engagements to build visibility in the tech community. Partnerships and internships. Educational institutions. Partner with universities and colleges to identify emerging talent through internships, co-op programs, and collaborative research projects. Industry collaborations. Work with other companies, nonprofits, and industry groups to sponsor events and programs that nurture AI talent. Continuous learning and training. Upskilling programs. Invest in ongoing education and training programs to help employees keep pace with advancements in AI, machine learning, and related technologies. Customized learning paths. Offer personalized learning paths that align with individual career goals and the organization's needs, leveraging online courses, workshops, and certifications. Mentorship and coaching. Guidance. Pair less experienced employees with experienced mentors who can provide guidance, feedback, and support in their professional development. Leadership development. Implement leadership coaching for high-potential employees to prepare them for future leadership roles in AI and technology. Performance management and feedback. Goal setting. Use performance management systems to set clear, measurable goals that encourage skill development and innovation. Regular feedback. Provide regular, constructive feedback to help employees understand their strengths and areas for improvement. Career pathways and progression. Clear progression. Define clear career pathways within the organization, showing employees how they can advance and develop their careers in AI and related fields. Opportunities for advancement. Create opportunities for advancement and encourage internal mobility to retain top talent. By focusing on both talent acquisition and development, organizations can build a robust pipeline of skilled professionals ready to tackle the challenges and opportunities presented by AI and technology. This strategic approach not only enhances organizational capabilities, but also contributes to the broader ecosystem by developing the talent needed for the future of work. Chapter 10. Vendor and Technology Selection. Vendor and technology selection is a critical process for organizations looking to implement or enhance their technological capabilities, AI, machine learning, and related systems. Making informed decisions in this area requires a strategic approach that aligns with organizational goals, operational needs, and future scalability. Here's a structured approach to guide you through this complex decision-making process. Define your requirements. Needs analysis. Clearly articulate what problems you're trying to solve or what objectives you aim to achieve with the new technology. Technical specifications. Identify specific technical requirements, such as performance metrics, compatibility with existing systems, and any regulatory compliance needs. Budget constraints. Determine your budget for both initial implementation and ongoing operation, including potential costs like licensing fees, customization, and support services. Market research. Vendor landscape. Conduct comprehensive market research to identify potential vendors and technologies that meet your criteria. This can involve reading industry reports, consulting experts, and attending trade shows or webinars. Technology assessment. Evaluate the maturity and stability of the technologies offered by these vendors. Consider both established solutions and emerging innovations that could provide a competitive edge. Request for information, RFI. Request for proposal, RRFP. RFI-RFP. Process. Prepare and distribute an RFI or RFP document to shortlisted vendors to gather detailed information about their offerings, capabilities, and pricing. Evaluation criteria. Define clear criteria for evaluating responses, including technical capabilities, cost-effectiveness, vendor reputation, and support services. Vendor evaluation and selection. Demonstrations and pilots. Request demonstrations and, where feasible, pilot implementations to see the solutions in action and assess their fit with your requirements. Reference. Checks. Speak with current and former clients of the vendors to get insights into their experiences, focusing on the vendor's reliability, support, and partnership qualities. Scoring and comparison. Use a scoring system based on your evaluation criteria to objectively compare the vendors and technologies. Negotiation and contracting. Negotiation. Engage in negotiations with the selected vendor to secure favorable terms, focusing on aspects like pricing, service levels, data ownership, and exit strategies. Contract review. Carefully review contracts with legal and technical advisors to ensure they align with your organization's interests and requirements. Implementation planning. Implementation strategy. Work with the selected vendor to develop a detailed implementation plan, including timelines, resource allocation, and risk management strategies. Change management. Plan for organizational change management, ensuring that staff are trained and prepared for the new system. Ongoing evaluation and support. Performance monitoring. Establish metrics and KPIs to monitor the performance and ROI of the new technology. Vendor support. Ensure you have access to adequate support from the vendor, including technical assistance, training, and updates. Key considerations: scalability and flexibility. Select technologies and vendors that can scale and evolve as your organizational needs change. Security and compliance. Prioritize solutions that adhere to industry-standard security practices and comply with relevant regulations. Cultural fit. Consider the vendor's cultural alignment with your organization, focusing on partnership potential and shared values. By systematically following these steps, organizations can make informed decisions that maximize the value of their technology investments, reduce risks, and support long-term success in their digital transformation initiatives. Chapter 11. Risk Management. Risk management in the context of AI and technology projects involves identifying, assessing, and prioritizing risks, followed by coordinated and economical application of resources to minimize, monitor, and control the probability or impact of unforeseen events. Effective risk management is crucial for ensuring the successful development, deployment, and scaling of AI initiatives. Here's a structured approach to managing risks in AI projects. Risk identification. Technological risks include issues related to data quality, algorithmic bias, model interpretability, and technological obsolescence. Operational risks encompass challenges in integrating AI systems into existing workflows, potential disruptions to business operations, and issues with user adoption. Regulatory and compliance risks arise from failing to comply with relevant laws and regulations, such as data protection and privacy laws, for example, GDPR, CCPA. Ethical and societal risks, concerns about ethical considerations such as fairness, accountability, transparency, and the potential societal impact of AI applications. Financial risks include budget overruns, unexpected costs, and potential impact on revenue and profitability. Risk assessment. Likelihood and impact. Evaluate the probability of each risk occurring and its potential impact on the project and the organization. This can be done using qualitative methods, for example, low, medium, high, or quantitative methods, for example, expected monetary value. Vulnerability. Assessment. Determine how vulnerable the project is to identified risks, considering existing controls and mitigation strategies. Risk prioritization. Risk matrix. Use a risk matrix to prioritize risks based on their assessed likelihood and impact. This helps in focusing efforts on the most critical risks. Dynamic prioritization. Recognize that risk priorities can change as the project progresses and as external conditions evolve. Regularly update the risk assessment and prioritization. Risk mitigation strategies. Avoidance. Take actions to prevent the risk from occurring, such as changing the project scope or using proven technologies. Reduction. Implement measures to reduce the likelihood or impact of the risk, such as investing in additional training or adopting best practices in data management. Transfer. Shift the risk to another party, for example, through insurance or outsourcing certain project components. Acceptance. For low-priority risks, it might be appropriate to simply accept the risk, recognizing that it is either unlikely or would have a minimal impact. Implementation of mitigation measures. Action plans. Develop and implement action plans for mitigating high-priority risks. Assign clear responsibilities and timelines. Technology. Solutions. Utilize technology solutions where appropriate, such as using secure cloud storage to mitigate data loss risks. Monitoring and review. Continuous monitoring. Establish mechanisms for ongoing monitoring of risks and the effectiveness of mitigation measures. This includes regular project reviews and risk assessments. Adaptation and learning. Be prepared to adapt risk mitigation strategies based on monitoring results and lessons learned throughout the project lifecycle. Communication and reporting. Stakeholder engagement. Keep all relevant stakeholders informed about key risks and mitigation plans. Transparent communication helps in managing expectations and fostering a culture of risk awareness. Documentation. Maintain comprehensive documentation of the risk management process, including risk assessments, decisions made, and the rationale behind them. Effective risk management in AI projects is a dynamic and continuous process that requires proactive identification, assessment, and mitigation of risks. By systematically managing risks, organizations can enhance the resilience of their AI initiatives, minimize negative impacts, and capitalize on opportunities for innovation and competitive advantage. Chapter 12. Performance metrics and ROI. Performance metrics and ROI are crucial for evaluating the success and value of AI projects. They help organizations assess whether AI initiatives meet their strategic objectives, optimize processes, and justify the investment in technology. Now, here's a guide on how to approach performance metrics and ROI for AI projects. Performance metrics for AI projects. Accuracy and precision. Measure the correctness of the AI model's predictions. High accuracy and precision are critical for applications like medical diagnosis, fraud detection, and customer recommendations. Recall. Sensitivity. Important for cases where missing a positive instance, for example, not identifying a fraudulent transaction, is costly. It measures the model's ability to detect all relevant cases. F1. Score balances precision and recall, providing a single metric to assess model performance, especially useful when dealing with imbalanced data sets. Latency and throughput. Measure the time it takes for the AI system to return a result, latency, and the number of units processed over a given period, throughput. These are crucial for user-facing applications and real-time processing needs. Scalability. The ability of the AI system to handle growing amounts of work or to be capable of expansion. It's essential for projects expected to scale up in terms of data volume or user base. Model robustness and generalizability. Assess how well the AI model performs on unseen data and its ability to maintain performance across different environments or data sets. User adoption and satisfaction. Reflects how well the end users accept and utilize the AI solution. High user satisfaction and adoption rates often indicate the solution meets its intended purpose effectively. Evaluating ROI of AI projects. Cost reduction. Calculate cost savings achieved through automation, improved efficiency, or reduced errors. This can include labor cost savings, lower operational costs, or decreased waste. Revenue enhancement. Assess any increase in revenue attributed to the AI project, such as through improved customer segmentation, personalized marketing, or optimized pricing strategies. Time to value. Consider how quickly the AI project delivers value after deployment. A faster time to value can justify the initial investment and indicate a successful implementation. Competitive advantage. Evaluate qualitative benefits such as improved customer satisfaction, enhanced product offerings, or a stronger competitive position in the market. Investment costs. Include all costs associated with the AI project, from initial development and training data acquisition to ongoing maintenance and infrastructure costs. Calculating ROI. Net benefits. The total benefits, revenue enhancement and cost reduction, minus the cost of investment. Cost of investment. The total expenditure on the AI project, including technology, personnel, training, and other related costs. Considerations. Long-term impact. Some AI projects may have a longer horizon before showing tangible ROI, especially those that significantly transform business processes or require extensive user training. Intangible benefits. Consider including intangible benefits in your assessment, such as improved brand reputation, customer loyalty, or employee satisfaction, which can be critical for long-term success. Benchmarking. Compare performance metrics and ROI against industry benchmarks or similar projects within the organization to assess relative success. Effectively measuring performance metrics and ROI requires a balanced approach, considering both quantitative and qualitative outcomes. By regularly monitoring these metrics, organizations can make informed decisions about scaling, optimizing, or pivoting their AI initiatives to maximize value and impact. Chapter 13. Industry Trends and Best Practices. Keeping abreast of industry trends and best practices is crucial for organizations aiming to leverage AI and machine learning effectively. These trends and practices are continuously evolving, driven by technological advancements, market demands, regulatory changes, and societal impacts. Here's an overview of current trends and best practices in the AI and ML landscape. Industry trends. AI and ethics. There's a growing focus on ethical AI development, emphasizing fairness, transparency, and accountability in AI systems to mitigate bias and ensure equitable outcomes. Explainable AI, XAI. XAI is gaining importance as organizations seek to understand how AI models make decisions, especially in critical applications like healthcare and finance. AI in edge computing. Deploying AI algorithms on edge devices, closer to where data is generated, reduces latency, decreases bandwidth use, and enhances privacy by processing data locally. Hybrid and multi-cloud AI strategies. Organizations are adopting hybrid and multi-cloud environments to deploy AI solutions, seeking to optimize compute resources and mitigate vendor lock-in risks. Augmented workforce. AI tools and systems are increasingly used to augment human capabilities, automating routine tasks, and providing insights to support more complex decision-making processes. AutoML and democratization of AI. Automated machine learning platforms are making AI more accessible to non-experts, enabling more users to create and deploy AI models without deep technical knowledge. Best practices. Data governance and quality. Implementing robust data governance and ensuring high-quality data are fundamental for developing effective AI/ML models. The accuracy of these models is heavily dependent on the data they are trained on. Continuous learning and improvement. AI/ML models should be continuously monitored, retrained, and updated to adapt to new data and changing conditions, ensuring their relevance and accuracy over time. Interdisciplinary collaboration. Successful AI initiatives often require collaboration across disciplines, combining expertise in data science, domain-specific knowledge, ethics, and user experience design. Privacy and security by design. Incorporating privacy and security considerations at the early stages of AI system development is essential to protect sensitive data and comply with regulatory requirements. Scalability considerations. Planning for scalability from the outset allows AI systems to grow and adapt as organizational needs change, ensuring long-term viability and performance. Stakeholder engagement and transparency. Engaging with stakeholders throughout the AI project lifecycle and maintaining transparency about AI systems' capabilities and limitations build trust and facilitate user adoption. Ethical and responsible AI. Adhering to ethical principles and responsible AI practices, including conducting impact assessments and establishing ethical guidelines, is critical for fostering trust and ensuring societal acceptance. Staying informed about these trends and adhering to best practices enables organizations to navigate the complexities of AI/ML implementation effectively. This will help harness the potential of these technologies to drive innovation and enhance operational efficiency. Chapter 14. Scalability and Infrastructure. Scalability and infrastructure are pivotal considerations in the deployment and development of AI and machine learning systems. As AI/ML applications grow in complexity and size, the underlying infrastructure must be capable of supporting increased workloads and the efficient processing of vast amounts of data. Here's an overview of key considerations for scalability and infrastructure in AI/ML initiatives. Scalability considerations. Horizontal versus vertical scaling. Understand the difference between scaling out, horizontal scaling, by adding more machines or instances to pool resources, and scaling up, vertical scaling, by adding more power, CPU, RAM, to an existing machine. AI/ML workloads often benefit from horizontal scaling due to the parallel nature of many AI/ML tasks. Distributed computing. Implementing distributed computing frameworks, for example, Apache Spark, Hadoop, allows AI/ML workloads to be processed across many machines, improving processing time and scalability. Elasticity. Cloud computing services offer elasticity, allowing the infrastructure to automatically scale resources up or down based on demand. This flexibility is crucial for AI/ML applications with fluctuating workloads. Statelessness. Designing AI/ML systems to be stateless where possible can enhance scalability. Stateless applications can handle requests independently, making it easier to distribute the workload across multiple computing resources. Infrastructure considerations. Data storage and management. AI/ML projects require efficient data storage solutions that can handle large datasets and support high-speed data retrieval. Options include cloud storage, data lakes, and distributed file systems. Compute power. AI/ML tasks, especially training deep learning models, require significant computational power. GPUs, graphical processing units, and TPUs, tensor processing units, are specialized hardware that can dramatically speed up these tasks. Wafer-scale integration is a new technology that will make AIs faster. Networking. High-bandwidth, low-latency networking infrastructure is critical for distributed AI/ML systems. This ensures rapid data transfer between nodes in a cluster and reduces bottlenecks in data processing. Cloud versus on-premise. Deciding between cloud-based and on-premise solutions involves trade-offs in terms of cost, control, security, and scalability. Hybrid models may also be considered to leverage the benefits of both. Security and compliance. Infrastructure must be designed with security in mind, including data encryption, access controls, and compliance with relevant regulations. For example, GDPR for data protection. Containerization and orchestration. Technologies like Docker and Kubernetes can facilitate the deployment, scaling, and management of AI/ML applications by containerizing them and automating their deployment across clusters. Best practices for scalability and infrastructure planning for scale from the start. Anticipate future growth in design systems that can scale efficiently from the beginning to avoid costly re-architecting. Monitoring and optimization. Continuously monitor system performance and resource utilization. Use insights gained to optimize the infrastructure for cost, performance, and scalability. Choosing the right tools and technologies. Select tools and technologies that best match the specific requirements of your AI/ML workload, considering factors like performance, community support, and ease of use. Emphasizing on data strategy. Efficient data strategies that address data collection, storage, processing, and archiving are crucial for supporting scalable AI/ML systems. Invest in skills and expertise. Ensure your team has the skills and expertise needed to implement and manage scalable AI/ML infrastructure. This may involve training current staff or hiring specialists with experience in cloud computing, distributed systems, and data engineering. Focusing on scalability and infrastructure is essential for unlocking the full potential of AI/ML initiatives. It not only supports current operational needs, but also lays the groundwork for future expansion and innovation. Chapter 15. Cross-disciplinary collaboration. Cross-disciplinary collaboration is essential in the development and implementation of AI and ML technologies, as these fields inherently draw upon and impact a wide range of disciplines. The integration of insights from various fields can enhance the effectiveness, ethical grounding, and societal relevance of AI/ML solutions. Here's a look at how to foster cross-disciplinary collaboration in AI/ML projects. Establish clear goals and objectives. Start with a clear understanding of what you aim to achieve with your AI/ML project. Ensure that these goals are understood and shared across the team, including how contributions from different disciplines can help achieve these objectives. Build a broad-based team. Assemble a team with a wide range of skills and backgrounds. This should include not only data scientists and AI experts, but also professionals from the fields of ethics, law, psychology, sociology, design, and domain-specific areas relevant to the project. For example, healthcare, finance, environmental science. Promote knowledge sharing. Organize workshops, seminars, and training sessions that allow team members to share their disciplinary knowledge and methodologies with others. This can help bridge knowledge gaps and foster a common understanding. Utilize collaborative tools and platforms. Leverage collaborative software and platforms that facilitate communication, project management, and documentation among team members working from different locations or within various fields. Adopt agile methodologies. Implement agile project management methodologies that emphasize flexibility, continuous feedback, and iterative progress. Agile practices can help accommodate the dynamic nature of cross-disciplinary projects and ensure that contributions are integrated effectively. Encourage experimentation and creative problem solving. Create an environment where experimentation is encouraged and failures are seen as learning opportunities. Cross-disciplinary collaboration thrives when team members feel free to propose innovative solutions and explore new approaches. Establish mechanisms for conflict resolution. Recognize that bringing together multiple disciplines may lead to differing opinions and approaches. Establish clear mechanisms for conflict resolution that focus on constructive dialogue and finding common ground. Align incentives and recognitions. Ensure that incentives, rewards, and recognitions are aligned with the goals of cross-disciplinary collaboration. Acknowledge and celebrate contributions from all disciplines involved in the project. Engage with external stakeholders. Extend collaboration beyond the immediate team to include external stakeholders, such as industry partners, academic institutions, regulatory bodies, and the communities affected by AI/ML technologies. Their perspectives can provide valuable insights and help ensure that the solutions developed are socially relevant and ethically grounded. Cross-disciplinary collaboration in AI/ML projects not only enriches the development process, but also enhances the robustness, ethical alignment, and societal value of the outcomes. By integrating different perspectives, organizations can navigate the complexities of AI/ML technologies more effectively and harness their full potential for positive impact. Chapter 16. Change Management. Change management, in the context of implementing AI and ML initiatives, is crucial for ensuring that the adoption of these technologies leads to successful outcomes. It involves managing the transition of people, processes, and technology within an organization to embrace new ways of working enabled by AI/ML. Here's how organizations can approach change management for AI/ML projects. Leadership buy-in and support. Engagement of leaders. Secure commitment and support from top management. Leadership should actively advocate for the change, demonstrating its alignment with the organization's strategic goals. Vision communication. Leaders must clearly articulate the vision and benefits of AI/ML initiatives, setting the tone for organization-wide acceptance and enthusiasm. Stakeholder engagement. Identify stakeholders. Map out all stakeholders affected by the AI/ML implementation, including employees, customers, partners, and suppliers. Communication plan. Develop a comprehensive communication plan that addresses stakeholders' concerns and expectations, providing regular updates on progress, impacts, and benefits. Cultural readiness and adaptation. Culture assessment. Assess the organization's culture to identify potential resistance or barriers to change. Understanding the cultural context is key to formulating effective change strategies. Fostering a culture of innovation. Promote a culture that values innovation, experimentation, and learning. Encourage an environment where failure is seen as a step towards innovation and discovery. Training and development. Skills assessment. Identify skill gaps that need to be addressed to effectively use AI/ML technologies. This includes both technical skills and soft skills related to new ways of working. Customize training programs. Implement tailored training and development programs to upskill and reskill employees, ensuring they are equipped to thrive in a transformed workplace. Employee involvement and empowerment. Participative design. Involve employees in the design and implementation process of AI/ML projects. This can enhance buy-in and help surface insights that lead to better outcomes. Empowerment. Empower employees to take initiative and make decisions within the new AI/ML enhanced processes. This encourages adoption and adaptation to new technologies and workflows. Change agents and champions. Identify champions. Identify and empower change champions within the organization who can advocate for and support the transition to AI/ML. Network of support. Build a network of change agents across departments who can provide peer support and promote positive attitudes towards the change. Monitoring, feedback, and adaptation. Feedback mechanisms. Establish mechanisms for collecting feedback from all levels of the organization regarding the AI/ML implementation. Continuous improvement. Use feedback to make iterative improvements. Be prepared to adapt strategies in response to challenges encountered during the implementation. Measuring success and communicating wins. Success metrics. Define clear metrics for success based on the objectives of the AI/ML initiative. This could include improved efficiency, cost savings, enhanced customer satisfaction, or new capabilities. Celebrating success. Communicate and celebrate early wins and milestones. Sharing success stories can build momentum and reinforce the value of the AI/ML initiative. Risk management and mitigation. Anticipate resistance. Identify potential sources of resistance and develop plans to address these concerns. Understanding the root causes of resistance can inform more effective mitigation strategies. Support structures. Provide support structures, such as help desks or mentorship programs, to assist employees in navigating changes and overcoming challenges. Effective change management for AI/ML initiatives requires careful planning, transparent communication, and ongoing engagement with all stakeholders. By addressing both the human and technical aspects of change, organizations can enhance the likelihood of successful adoption and realization of the full benefits of AI/ML technologies. 1. Overview. 2. AI and machine learning fundamentals. 3. Data management. 4. Ethics and responsible AI. 5. AI strategy and implementation. 6. Regulatory compliance. 7. Innovation management. 8. Stakeholder engagement. 9. Talent acquisition and development. 10. Vendor and technology selection. 11. Risk management. 12. Performance metrics and ROI. 13. Industry trends and best practices. 14. Scalability and infrastructure. 15. Cross-disciplinary collaboration. 16. Change management.